about excuse me, correlation and causation. We did correlation last week with scatter plots, but causation, which is this term right here, is something else entirely. All right, they might be related, they might not be. So causation occurs when a change in one variable produces a change in another variable. So it's the cause and effect relationship. So the first thing causes the second thing to happen. So some things, they might have a positive correlation but not be related whatsoever. So it's just kind of almost a coincidence. But if it's a causation, the first thing causes the second to happen. So correlation can be observed between many different variables. Causation might be affected by outside things that we don't know about. So as we go through this, I'm going to be writing up different explanations. Your homework is online, so the explanations are kind of filled in for you, and there's going to be different drop-down menus, kind of similar to some of the assignments from last week. But whatever you put in there has to make sense. So we're going to just talk about a few things there. Okay. So correlation versus causation. So the data in this scatter plot shows the per capita consumption of mozzarella cheese and the number of civil engineering doctoral degrees awarded in the United States. Determine whether the data plotted on the graph illustrate a correlation or causation. Do you see a correlation in the scatter plot?
Yeah.
What type?
Positive.
Okay. So there is a positive correlation. Now, some of these, there's going to be a correlation and a causation. Some of it is just a correlation. Some of it, quite possibly, could be a causation only. But most of the time, it's either both or just correlation. Okay. Now, it's a causation if the first, or if the X value, so that would be mozzarella consumed, causes the doctoral degrees to happen. Are those two things even related? No. Nothing whatsoever. So this is what we would call a coincidence. Okay. So the way you would describe this, and I'm just going to be checking my notes just to make sure I get the phrasing right, because a lot of these phrases are very similar. So I'm not going to write everything, but these are not related whatsoever. So the amount of mozzarella consumed does not cause a certain number of doctoral degrees to be had. Okay. Because there's no relationship whatsoever. So we would say, and this is how you'll fill these in, so I'll show you where like drop-down menus may happen. So there is a correlation. It might ask you for what type, but whether or not there's a correlation could be positive or negative. So there is a correlation, but not causation. So these might be drop-down menus in your homework, where it'll say like, it'll say there is a correlation and a causation, there is a correlation but not a causation. And there might be different reasons, so make sure your reason makes sense. So the reason on this one would be cheese has nothing to do with a degree in civil engineering. Okay, at least I hope not. Okay, so that's what we would call just a coincidence. So there's a positive correlation, but that does not cause the other thing to happen. Yeah.
So if they were related, would it be there's a correlation and a causation?
Yeah, or at least likely a causation. Because some of them, there's some gray area. This is definitely, there's no relation whatsoever. Okay. All right. Not too bad? Okay. Now, some of them you won't have scatter plots. You're welcome to make one. I'm not going to require that you do. But you should be able to look at some points in the table and just figure out whether there is a correlation or not. But if you need a visual, by all means, draw a scatter plot. Okay, that will be optional today. So we're going to determine whether the data in the table represents a correlation or causation, or possibly both. So we have different months of the year. So March, April, May, June, July, August. There is sunscreen sold. I'm assuming bottles or containers of some kind. And then there's sunglasses sold. So if you want to make a scatter plot, by all means. Okay. So it doesn't really matter which one's the independent or dependent. Okay, so this was the X and this was the Y. Okay. As it moves from March to August, what's happening to the sunscreen? Increasing or decreasing? Increasing. What about sunglasses?
Increasing.
Also increasing. So if both are increasing, what type of correlation is that?
Positive.
Okay. So there is a positive correlation. How about a causation? Does the amount of sunscreen sold cause a certain amount of sunglasses to be sold?
No.
No. Could they be related? Probably, depending on how much time spent outside. But there's no cut and dry. The first thing does not cause the second thing to happen. Now, if it said temperature to that, likely. Okay. But there's still no causation. Would there be a relationship? Probably. But some people wear sunglasses, some people don't. It just depends. All right, but this is still not causation. Okay, so you have to think about it. There's a correlation, which means they're both increasing, which makes sense. Okay, generally, the more people buy and wear sunscreen, a lot of people wear sunglasses, but some people don't like sunglasses. So there's some variance there. But sunscreen sold does not cause the number of sunglasses to be sold. There's probably a relationship, but there's not a cause and effect relationship. So causation is very specific in that aspect. Okay. So you see, it could be open to interpretation, but really think about that objectively. Does the first thing cause the second thing to happen? Okay. There can be a correlation, but no causation. All right. Questions about that? So really try and change your thinking. They are related, which is some of the correlation, okay, but it's not a cause and effect relationship. Any questions on that? Okay. So we had a physical graph, we had a table. Again, you can make a graph if you really want to. That's totally your choice. Now you have a statement. So we're going to talk about this one too. So determine whether the situation illustrates a correlation or causation, and we're going to explain our reasoning and include other factors that might take into account here. So a university experiment showed a negative correlation between the average weekly time spent exercising and the probability of developing heart disease. Okay, now I'd already determined there's a correlation. Okay, so explaining why that's a negative correlation. Okay, so to explain this if you had to. So as the time spent exercising increases, oh, I can't spell. Exercising increases, the probability of developing heart disease decreases. So use the same words that are in the statement. That would explain the correlation. Okay, so explaining your reasoning. So that's what negative correlation means. Do we think this is a causation?
Yeah.
Yes.
In what way? Like, explain your thought.
The time spent exercising causes a probability.
Being healthy.
Now, you don't necessarily have to use the words up here. So are you guys telling me, generally speaking, is this a proven statement? Maybe, maybe not. Okay. But generally, more people that exercise probably have a decreased probability of developing heart disease. Okay. So you can do that in your own words. Okay. So now there's some things that if it's a proven fact, like if I change this to the amount spent exercising and the amount of calories burned, is that a proven fact? You exercise, you're going to burn calories. That is a definite causal relationship. This could be. Okay, so the key phrase there could be. So this could be, and you're going to see these as options in your homework. So it could be, or it could not be, might not be, stuff like that. So this could be a causation, okay, for that reason, because the more you exercise, you could be at less of a risk of heart disease. like that in your own words. You don't have to have the exact same wording. Again, most of the explanations are gonna be done for you on that aspect, but you might have a test question like this. Okay. Now, the other thing, what other factors might be involved that could affect whether this is causation or not? Diet? What else? For heart disease? Family history. So genetic disposition? Okay. So if it says other factors that might be involved, you can think about that. So somebody's diet, okay, they can exercise all they want, but if they eat like crap, it's probably not gonna help anything. Okay, diet, family history of heart disease. Anyone think of anything else? Those are the two that came to my mind.
Maybe like the air quality, sometimes like that.
Air quality, depending. I guarantee around Vegas it's not great. But different things like that. So some of that, like you guys might have experience with that in your family. Someone has heart disease, so that might come to you right away. If you guys haven't experienced something like that, you might not know what to think. Okay, stuff like that. Could be what type of exercise, different things like that. So this is your key phrase here. So this could be a causation versus if it was time spent exercising and calories burned, that is a proven fact that happens. Okay. So a lot of these could be, might not. These outside factors may have an effect on that. Okay. So you'll see once you get started in your assignment, there's going to be different drop downs, but your statement should make sense. So make sure to read through it before you hit submit, and you can retry it a couple times before it counts it. But whatever score you get is the score I'm going to give you. Okay. Not too bad. Make sure to think about causation as a cause and effect relationship. Okay. All right. So